8.4. Today, or in these notes, we are going to be using the quadratic formula so that we can find the value or values of x. And you can do it when you can plug in and solve for x. And we're going to do that in the quadratic formula. So let's just take a quick journey with me. I know I've got this written down here, but take a quick journey with me on factoring. The idea behind factoring is that we have some kind of value squared in an expression. So whether that is x squared plus 3x plus 2 equals 0, okay? And we've learned different strategies, right? We would plug this in. It's a trinomial, 2 and 3, so 1 and 2, right? And so it's x plus 1 times x plus 2, and those multiply to make 0, and then you would split that to find the value of each x here. This is just review of what we've done, right? We've also learned how that works with a leading coefficient and how that it changes things, how we would multiply here and use a 4, and then we would have to figure out, you know, if anything multiplies to 4 and adds to 3, whatever. So there's like, and we still solve. We've also learned how to solve taking the square roots. So if we have a quantity and that quantity is squared, we can solve taking square roots to find the value of x. That would be a 3. And then, again, we could split this and solve. We also learned how to solve for x by completing the squares. So let's say we had x squared plus and you would complete the square if you have a leading coefficient and nothing that works. So like for 9. So we would complete the square if I have 9 on top and 4 on the bottom, and my factors of 9 are 1 and 9, 3 and 3, and none of these make 4. So we would complete the square if we don't have a leading coefficient, and especially if we have an even number here, right? We would move the 9. This was 8.3. So I'm just giving you a brief overview of like all of these things are connected. All of these strategies, all of this stuff that we've done is connected with how we solve for x, how we find the value of x. And there are certain patterns that apply that allow us to use essentially shortcuts to figure out what the value of x is. So for this one, I take 4 and I divide it by 2, and then whatever I get, I'm going to square. So 4 divided by 2 is 2, and 2 squared makes 4. And then that creates a pattern of x plus 2 quantities squared equals, I also have to put a 4 over here, and this would be -5. So this was a bad example because I got an imaginary number, but then you would square root, right, to solve for x. So there's lots of things that we've learned. Today's lesson, so all of these ways have been shortcuts based on the patterns that exist that allow us to find the value of x. Now, sometimes none of those shortcuts work, and that's where the quadratic formula comes in. I will say that the quadratic formula is a formula that could be used in every single one of these problems that we've done leading up to this. So leading up to 8.4 and everything from 8.3, 8.2, 8.1, stuff that we've learned from Unit 7, all of it builds up to, or could have been solved using this formula. And this formula is derived from, or it comes from, completing the square from standard form. So hang with me here. If we have standard form, which is a number, right, ax squared plus bx plus c. These are our a, b's, and c's. And if we were to go through and mathematically complete the square without like using any values, we would have to look at all of this math. We would do all of this math to get x by itself, and it leads us to this formula. So you don't have to learn how to do this abstract kind of math stuff, but essentially the math that it takes us to get from this to x by itself right here, all of this math that takes place in between allows us to get x by itself. And that's where the quadratic formula comes from, okay, or how we can derive it. So now I'm going to zoom in here. Please take a moment to write this down while I read it out. So the quadratic formula is x equals negative b plus or minus the square root of b squared minus 4 times a times c. And all of that is being divided by 2a. And in the past in class, we've done different things to help you memorize this. We're allowing you to use notes on a lot of your stuff. So it's probably just handy to have this available so that you can reference it. But the way that I learned it and remember it is a story. X equals, so here's the story. There was a negative boy that was indecisive, plus or minus, about going to a radical party. See this radical? He didn't want to be square or negative around 4 awesome chicks, and the party was all over at 2 a.m. So that's the way that I remember it. It's just a fun little story. Again, you're going to be able to reference this, so memorizing it would be helpful, but you can reference it. So how does this quadratic formula work? Well, the first thing is we need to make sure that our problem is in standard form. So that means that everything's on the left and it's set equal to 0. From there, we're going to label some things, and I'm going to write in some things that are missing. So there is a 1 sitting next to my x, and that 1 is the value of a. I also have this 9. That's our b. And I have this negative 90, and that's our c. So a is 1, b is 9, and c is negative 90. And it may be helpful for you to initially write it off to the side here. 1, 9, negative 90. And now we are going to take the quadratic formula and simply replace a, b, and c with these values as we come across them. So you may want to write the quadratic formula again in the corner. The more you write it, the better you'll get at it. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So let's start replacing stuff. X equals negative, and then instead of b, I'm going to plug in a 9. Plus or minus the square root of my b value squared. So my b value again is 9. Minus 4 times a times c. So my a is 1 and my c is negative 90. And it's all over 2 times my a, which is 1. We've done no math yet. All we've done is we've replaced variables with numbers, with their corresponding numbers. So I replaced my B's, I replaced my A's, and I replaced my C. The next thing we're going to do is start evaluating this. So there are certain parts of it we can evaluate. We're going to work through the order of operations. So if you want to, you can apply this negative to the 9. So it means the opposite. This is the opposite of positive 9, which means I just have a negative 9 here. Plus or minus the square root. And now I'm going to work out this piece here, 9 to the second power, 81. And then I'm going to work this piece out, a negative 4 times 1, which is negative 4, times negative 90, which is positive 360. And then down here I'm working out 2 times 1, which is 2. Okay, my next step, I'm going to add these together. Nothing else changes. So x equals negative 9 plus or minus the square root. I now have 461. When I do 81 plus 360, I should get 41, and that's still all over 2. And now my next step is to look to see, can 461 be broken down? It cannot. And I don't think we're going to break these down too much. The ones that you get shouldn't break down. Or we're going to have a perfect square. There's no perfect square here. So we're also going to look at, can 9 and 2 reduce? This 2 can't reduce with the 461 because it's protected by the square root. But this 2 could reduce could potentially, actually it's not true because we'd have to have 3 things that reduce to reduce everything. So my mistake, don't immediately just look here and here. There's a third place, which is out front of our radical. So everything has to reduce. In this case, it doesn't. So this is our solution. This seems confusing. It's really, conceptually, it's not very hard. Here's a formula, plug things in, evaluate. It's the evaluating part that's mathematically a little bit challenging. And for these, remember the quadratic formula, as with all of these other things, we follow our process. So our flow chart, right, is GCF, and then we have 2 terms, which we factor by grouping. We have 3 terms, which is now turned into big X with a leading or without a leading coefficient, or we could square root can't spell square, or we could complete the square or we can do a quadratic formula. It depends on what conditions exist. So with 3 terms, you can use the big X. You could take the square root. You could complete the square. Or now we're looking at, we could use the quadratic formula. So there's a bunch of strategies for 3 terms, depending on the patterns that exist in the 3 terms. We always want to do the easiest one. And then 4 terms is to factor by grouping. So all of this to say that quadratic formula still falls underneath GCF. So we're always looking for a greatest common factor first. So in example B, I have a greatest common factor of 5. That means I can divide 5 from this side. I'm going to scale this whole thing down by 5. But remember, what I do to one side, I have to do to the other. So if I scale this whole thing down by 5, I'm dividing all 3 of these things by 5, and I'm getting 1x squared plus 1x minus 12 equals 0 divided by 5, which is 0. So this is my new equation I'm working with. Quadratic formula tells me I'm using 1 for A, 1 for B, and negative 12 for C. So again, A equals 1, B equals 1, C equals negative 12. And now we're going to start filling this out. So remember our quadratic formula. X equals a negative boy that was indecisive about a radical party. He didn't want to be square or negative around 4 awesome chicks, and the party was all over at 2 a.m. So I'm going to start replacing some stuff. X equals negative b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. So let's fill this out now. My b is 1. AC, so my a is 1. And my c is negative 12. So those are the 4 things I need to fill in, or 5 things. And then we just start working it out from here. X equals, the opposite of 1 is negative 1, plus or minus the square root. 1 squared is a positive 1, so 1 to the second power, I work that out, it's positive 1, minus 4 times, negative 4 times 1 is negative 4, times negative 12 is positive 48. So actually, I'm sorry, this minus, I work that out here. And then over 2 times 1, which is 2. So now let's clean this up. 1 plus 48 is 49. X equals negative 1 plus or minus the square root of 49 over 2. And I'm going to move a little bit further over my box just so I have room to work. So the square root of 49 is 7. So now I'm working with x equals negative 1 plus or minus 7 divided by 2. And I'm going to split that up. I'm going to work that out over here. So x equals, I have a negative 1 plus 7 divided by 2, or x equals negative 1 minus 7 divided by 2. That plus or minus, right? So that plus tells me I could add 7. That minus tells me I could also subtract 7. When I work this out, x equals 6 over 2, so x equals 3. When I work my other one out, x equals negative 8 over 2, or x equals negative 4. And those are our 2 answers. I'm going to skip C. If you'd like to practice it on your own, you can. It's similar to B in that you could divide out 4 from this side and a 4 from this side and scale your problem down to x squared minus 2x minus 12 equals 0, and then you could plug in from there. I'm going to jump over to D and work on this one. There's no greatest common factor. So my A is 5, my B is negative 3, and my C is negative 10. And now I'm just going to plug these into my quadratic formula. So again, x equals negative b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. And now I just got to plug some numbers in. So my a is 5, my b is negative 3, and my c is negative 10. So negative b, which I'll do in green, so, and b squared. I'm replacing a and c. I'm replacing a with 5 and c with negative 10. And then again, I'm replacing a with 5 down here. And then I'm just evaluating this. Now I'm just working this out. So here's my new line of work. X equals the opposite of negative 3 is positive 3. So a positive 3 plus or minus the square root of negative 3 squared. Negative 3 times negative 3 is positive 9. So I'm getting a 9 in here. And then I'm doing negative 4 times 5, which is negative 20, times negative 10, which is positive 200. And all of that is over 2 times 5. Oh, I'm sorry. I'll work that out. It's 10. 2 times 5 is 10. Okay. So now I got to put 9 and 200 together. I mean, I guess you could do this. 9 plus 200 is really 209. So then we're going to look, can we take the square root of 209 like we could of 49 last time? And we can't. We can't take the square root of 209. So this is our answer. So it's about plugging things in and then working it out.